Hello guys and welcome to this video. In this video I'm going to code a very simple algorithm, comparison based sorting, quick sort. Why am I doing this? Because I've literally not been writing any code for a very long time, and so I thought maybe I should get back into it. To get started, quick sort is a very common and very sort of widely used sorting algorithm, also a good way to practice divide and conquer algorithms, which are very essential actually, in terms of solving computational problems. One of the different ways of solving different kinds of computational problems. So let me just quickly try to write this thing down. Quicksort, as you guys all know, works based on a special function which we call partition. Partition essentially just means find the random element in the array, and in the partition function is supposed to just put that element in its right position. So I'm going to talk about it more as we go. Let's at least get started. I'm just going to write the main function so that we can take our inputs. Wow, it's been so long since I've written any code. Kind of, I don't know, man. Maybe I will make some basic mistakes. Hopefully not. Alright, so let's get the scanner set up. Int n will get the size of the array, right? Let's get the array itself. Okay, hold on. What else? Okay, let's write a for loop to get the array input. I want to do this quickly so that we can move on to the actual part of the problem, which is writing the partition and the quick sort functions itself. So this should be done quickly, I guess. All right. So we have the inputs. Now what we have to do is call the quick sort function, which we are going to write in a second. We'll pass the array. We will pass the lower index, which is 0, and the higher index, which would be, well, n minus 1 in this case, right? It's a 0 based array, so 0 to n minus 1 for an array of size n. Okay, that should be good enough. And then at the end, obviously we'll print out the array after it has been sorted. So let me just quickly write that down as well. So we'll just say something like this. Fair enough. Now let's quickly implement the quick sort function. I'm going to call it quick sort. Takes the array as the input, a low index and a high index, right? What does it do? It checks. So if it's a divide and conquer algorithm, and we're going to recursively call this quick sort method, right? What is the basic principle? You should have an exit condition, otherwise you're going to an infinite recursion, and that is a horrible thing. No infinite pursuits in recursion, man. Alright, so okay, what is the exit condition? Okay, so if your low becomes higher than or equal to high, right, which means you really have nothing in the array left to process in terms of breaking down the array in for recursion. So in that case we'll just return, I think that should be correct, right? Okay, and then otherwise we have to split the array. So that split will be done on the basis of a pivot. Pivot is just the correct position of an element in the array. So yeah, so we will call the partition function, which will take the array as the input, right? And what else? Low and high, that should be it. And then of course you call the quick sort again on the array, low to pivot minus 1, right? And what else? Pivot plus 1 to high. Interesting. That should be good enough. What else? Now let's quickly write down the partition function. What does the partition function do? Wait, did I miss something here? I did. Static. Why is this? Okay, just write this down. and partition. Again, this takes low and high, right? Fair enough. What does the partition function do? Good to take an example and work it out before I code this thing down. So let's take an example right here quickly. Let's say we have an array of size 5. Maybe I'll take this as 2. Maybe this should be 4 actually. Yeah. So if this is the array, right, what would the partition function do? It would take some element as the pivot, move it to the beginning of the array. So let's say we choose 4 as a pivot element. By the way, that needs to be picked randomly, so we'll do that later. But for now, let's say 4 is the pivot right at the beginning of the array. So we need to put 4 in its right position such that every element to the left of 4 is less than or equal to 4. Every element to the right of 4 is greater than 4, right? So we obviously do this in one linear scan of the array. So you have a current pointer. Let's say the current pointer is pointing to low plus 1. Fair enough. The boundary is initially set here. So what we do is we compare 5 with the pivot 4. Is 5 less than or equal to 4? No, it isn't. So we move on. Current pointer now moves here. We can compare 3 with 4. Is 3 less than or equal to 4? Yes, it is. So then initially your boundary was here. Your boundary now moves here, and we swap these two. So now we are left with something like this. And now your boundary is here. Now the current moves next, so now we consider 8. Is 8 less than or equal to 4? No, it isn't. So if we move again, is 1 less than or equal to 4? Yes, it is. So the boundary advances here, and we swap 5 and 1. So we swap 5 and 1, right? And now we are done with the linear scan. We have processed every element in the array, and our boundary is currently here, right? So now what we can do is simply swap our swap our pivot element with the index that is currently pointed to as the boundary. So we will swap 4 and 1. So we have 1, 3, 4, 8, 5. Right now 4 is in its correct position. Every element towards its left is less than or equal to 4. Everything towards its right is greater than or equal to 4. So now you can just recursively call quicksort on the left part of the array and on the right part of the array. So you've effectively split your problem in this case into, well, exactly into a problem of size n by 2, but maybe not always the case depending on how you choose your pivot. So yeah, that's what the partition function is going to do. Let's quickly code this thing out. How many minutes into the video? 8 minutes. All right. So how to do this? We will take let's code this thing out. We'll take two variables, current equal to low plus 1. We'll have a boundary which we'll set to low, right? What else? We'll take a pivot which would be ARR low, and we can write a for loop while current is less than or equal to, or well, we can do a while loop or a for loop. So we will scan the entire array. What happens in the array if ARR, if the array, if this is less than or equal to pivot as we discussed, then what we do is we will increment our boundary and we will do a little swap here. What do we swap? We'll swap current with boundary. We'll quickly write down that swap function, but apart from that, we will increment our current pointer. At the end of this, what are we left with? Okay, we need to do one more swap, right? The array, low, and boundary, and we return the boundary. This should be good enough. Let's quickly write down the swap function, which is straightforward, hopefully. Void swap takes the array, takes, well, let's just call it two indices that we need to swap, take a temporary variable, let's say we store the element at index x into the temporary variable, and then element of at index x becomes, right, this ought to do it, right? Just want to make sure this is correct. Alright, so temp gets what is here. This is a 2i and it's a temp. Alright, this should take care of the swap. So I think we have our partition function. This should be working, and our main function is going to call and print. Let's get rid of this for now. What else do we have? Quicksort is going to have a exit condition. It's going to find a pivot and call quicksort low, pivot -1 and pivot +1 to high. Just want to make sure this is at least, on just if I just read through the code, I don't see a mistake. Maybe there is. We'll find out when we run this. Inside the partition function, we take a current pointer, set it to low +1. The boundary is initially set to low. The pivot is set to ARR low. We'll do one thing here. We'll obviously try to randomly pick a pivot, but we'll do that in a second. Or maybe I should do that right away. You know what? Let me at least run it once. So we'll run quicksort. Hold on, let me quickly terminate. Let's just run it from here. Alright, so let's take a simple example of 5 elements. 2, 1, 3, 4, let's say 6, 5. Okay, sort. Looks good. In order to be able to test this properly, maybe I should do something else. I'll put it in an infinite loop so that we can test true. Oh, these are the things you forget when you don't code for so long. Alright. We can test multiple inputs together. So 5, let's say we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Fair enough. Let's say we have 3 elements. 3, 2, 1. It sorts them correctly. Let's say we have 4 elements. 2, 1, 4, 3. That works fine. Let's say we just have the one element. That looks good. Alright, let's say we have nothing. Okay, that looks good. And let's say we have 10 elements, something like this. 56, 1, 4, 78, 23, 110. How many? 10 elements. Then 2, 5, 3, 45. How many do we have? Yeah. Looks to be sorted, right? It is. Cool. Let's take one more example of 10 elements, but we'll have lots of repetitions. Wait, hold on. 10 elements. We'll have a lot of repetitions. So we'll say 2, 3, 4, 1, 2, 2, 13, 2, 14, or maybe 11, 2. How many do we have? 1, 2, 3, 4, 5. Alright. Alright. Looks good. I think I was able to get the quicksort working now, obviously very quickly. As I said, let's do one more thing real quick. In terms of choosing the pivot, right, this is not the right thing to do. So what we can do is we can say int random index is equal to get random index between low and high. Now once we get that random index, and we can write that function in a second. Once we get that random index, what we can do is we can swap the array position low with this random index, and then we can say we can set up pivot like this. So then we're not just choosing the first element as the pivot every time, but we choose it randomly, and that is actually what makes quicksort work in n-log n time. So obviously I'm not going to go into the details of why that is, or how that is rather, but if anybody's watching this video, you can obviously read about it a lot on the internet or on YouTube. There are a lot of resources. Real quick, let's write this function down. Public static int get random index min max, right? So we pass low and high. Okay, how do you do this? Obviously if min is greater than max, we can what do we do in this case? We'll probably just, okay, I'll just throw an exception, I guess. Illegal argument exception. Is this the right exception to throw? Yeah, fair enough. Alright. Otherwise, we can return, right? We have a random, yeah, in java.utils dot next int. Now, how do you do this? You need a random number between min and max. So max minus min, right? Max minus min. If we do this, max minus min plus min, this should be good enough, I think. Is it? You know what? Let me actually quickly check this thing out. Just for a second, I'm gonna comment this thing out. And hold on, I need to plug in my charger as well. Yeah, let's see. Maybe you can get random index. Let's say we'll have a few examples. Right, 17 minutes. I want to keep this under 20 minutes, of course. Don't want to make it too long. Between 5 to 10, let's say. I mean, I don't even know why I'm doing this, because oh, that is why. So where does it fail? This guy. Okay. Okay, that's fine. That is fine. That is fine. We are throwing an exception. But let's just run this again. Okay, 0 to 10, 5, 0 to 1, 1, 0 to 1, 0, and 5 to, okay, this is fine. That should work. And let's just get rid of all of this and uncomment all of this. I think we are in business. So we have a randomized quicksort with 2 partitions, and it should work. It should work. It should work. Right, it should work. It should work. Am I missing anything? Just want to make sure everything is in place. Okay, let's quickly run this again. I just have 1 minute left. So, oh, interesting. For some reason, it had some problems with the imports. Alright, guys, we'll run this again. But yeah, as we come to the end of this video, if you guys like this video, just hit the like button. Subscribe to my channel for more live coding. And if you guys want me to work on a specific problem or code out something specific, leave that as a comment in the comment section below. And what else? Don't forget to like my other channel, which is actually my main channel, and I make a lot of videos on that channel. And stay happy, do what you like, enjoy life, and this seems to be working fine. Alright guys, thank you so much for watching this video. I will see you guys again in another video very soon. Till then, take care. Did we just blow up here? Oh, there you go. Alright guys, bye for now. This seems to be working fine.